Geometry notes for lesson 1.4. Okay, it starts off just by making sure you know some basic vocabulary. So vertex, the vertex of an angle is the common endpoint of the rays. So if you look at this picture off to the side, here's a ray going up this way and here's a ray going off that way. So the common endpoint, which is where the two rays meet, is the vertex. So the vertex is just a point where two rays endpoints meet. So it's also another, usually the corner of your angle is an easy way to kind of remember it too. But the technical definition is the endpoint of two rays where they meet. Okay, there are some specific ways you can name angles. So you can name it by its vertex. So angle Z. So you could name it, this is already right here, but angle Z, this is the symbol for angle. So it looks like a less than sign, but that's how you write angle. So that's angle Z. Another way to name this angle is by going from the rays to the vertex to the other ray. So this could be angle YZX. So angle YZX. Or you could go the other direction, angle XZY, angle XZY. And then the last way is if there's like a number or a letter or something inside here, that would be another way to name it. It's angle 1. So something that you cannot name it is starting at Z. So you can't call it angle ZYX. It would need to go in the order from either left to right or right to left. Like you need to have your center letter be the vertex. So Z was always in the middle here. So you can't just hop around. It needs to go in order one way or the other. Okay, an acute angle is between 0 and 90 degrees. So this is an acute angle. 90 degrees would be exactly a right angle. A lot of times you see a little box in there to show that it's a 90-degree angle. An obtuse angle is greater than 90 degrees, but smaller than a straight line. So between 90 and 180. And then the measure of a straight angle, it just looks like a line, but it's actually called a straight angle, is exactly 180 degrees. There's one more that I wanted to add to your notes. It is, let's say you started right here and you measured all the way around and then came back to the beginning point. So that is called a circular angle. And obviously, I bet you guessed it measures 360 degrees. Good. Okay, anything less than 360 but bigger than 180 is called a reflex angle. So let's say I'm going to add this to your notes too. Let's say I have an angle in here like this, but we're not measuring the acute part. We're measuring from here all the way around to here. That type of angle that's between 180 and 360 is called a reflex angle. And again, it is between 180 and 360 degrees. So it's smaller than 360, but greater than 180. All right, let's go on to the exercises. So what are 3 other names for angle S off to the side? So you can name it again by its by its number. So it could be called angle 3. It could be called the angles going in order from the ray to the vertex to the other ray. So RST, angle RST. It could go the other direction, angle TSR. And you could also just name it by its vertex angle if there's only one vertex there. So there's only one, so it's angle S. What I meant by only one is it could be confusing because if you look back up here, if I had drawn another ray coming off of this, and let's call this point Q, I don't know, you can't just call the vertex angle Z now because there's 2 angles at angle Z. So if I said this is called angle Z, would you be talking about this angle Z or this angle Z? So actually you can only call it angle Z if there's only one angle there. So there's only one angle here, so you can call it angle S. All right, what type of angle is angle S? You see the little box in here, which denotes an exact right angle 90 degrees. So it is a right angle. Name the vertex of each angle. So what that means is LGH, so from, if we drew a picture, L to G to H, L, G, H. What would be the vertex? The vertex, again, is that center dot, so it would be angle G. So the vertex of angle MBX would obviously be the center one, so it would be angle B. All right, number 4. Classify the angles as acute, right, obtuse, or straight, and these are based on assuming that these numbers are degrees. So angle LGH measures 14 degrees. So it's a tiny, tiny little angle, and that would be acute. This is actually a good time to pause the video and try these on your own, and then fast forward and see if you got the right answers. 90 degrees is right. I know I'm going out of order. Sorry, I went from 4 to 6 to 8, and then I'm going to jump back over here. 179 is really big. It's obtuse. Not quite a straight line, though. SRT is 114 degrees, so that would also be obtuse. 139 would also be obtuse. And 73 is less than 90, so it is acute. All right, we're going to use a protractor now to measure these angles and tell me how many degrees they measure. This might be a little tricky, but I think they all ended exactly on like a number or a 5 or something like that. So angle ADB, A to D to B. So it starts at 0 and goes up to 25. So this should be 25 degrees. One of the things I don't want you to get confused about is it's actually also on 155. If you look, it's on 155, and it's also on 25. It just depends on if you look at the inside or the outside. And I just want you to make sure it makes sense to you. Obviously, this is a tiny angle. It's not even a 90-degree angle, so we're going to go with the smaller numbers up here, the acute numbers up top. So just make sure it makes sense to you. It wouldn't be right to say 155 degrees when it's a tiny acute angle. Okay, I'm going to keep going down. Sorry. BDC. So from B to D to C. This one looks like it's also acute, so we're going to use these top numbers. And it went from 25 to 80. So 80 to 25 to 80, you're just subtracting. You're finding the difference between the two. So that should be 55 degrees. Angle ADC, ADC, is also acute, but barely. It's actually pretty close to a 90-degree angle. So it's right here, which is on the 80. BDE, B to D to E. So this one is bigger than 90, you can tell. So we're still going to use the top numbers. Actually, it wouldn't matter on this one if you use the top numbers or the bottom numbers. You're still subtracting to find the difference. So I'm going to use the top ones. So 25 goes all the way over here to 145. So just be sure if you're using the top numbers, you use the top numbers on both. So just be consistent. So 25 to 145 is 80. No, I lied. What is that? 25, 100, it'd be 120. If you're not sure, just subtract. So we've got 145 minus our 25. Let's just double check that. 120. So 120 degrees. Okay, and then let's try BDF. So B to D to F, B, D, F. This is a really big one. So I'm going to use the top numbers again. Actually, I'll use the bottom numbers. 0 all the way over here to 155. So that just told us. We don't have to do any subtracting. So 155. Okay, let's look at angle FDE. F to D to E is 0 to 35. So it's acute, and it's just 35 degrees. CDE, C to D to E, is in here. We're going to have to do some subtracting. So I'll just use this lower number. So it's at 100, and it lands right here at 35. So 100 minus 35 would end up being 65. Double check me on these numbers. Angle FDC, F to D to C. It's a little bit bigger than 90, so I'm going to start at 0 and read all the way over here to 100. And then the last one, ADE, ADE, bigger than 90, it's going to be an obtuse angle. So I'm going to start at 0, and it ends way over here. 0's on the top, so I'm looking at the top numbers, at 145. All right, on the next page, we are talking about angle addition postulates. These are exactly like the segment addition postulates that we've already done, but it's just angles this time instead of segments. So what they're saying is this little m stands for the measure of angle. So when you're reading it, you say the measure of angle AXB, which is this one on the left, plus the measure of angle BXC, which is the one on the right, equals the total measure of angle AXC. AXC is the whole thing. So this angle plus this angle equals the measure of the whole angle. All right, and this is an example of when you can't call it angle X. You never saw it called angle X anywhere because there's two angles at vertex X. So you would have to use all three letters this time to name them to be sure you're talking about the correct angle. Okay, let's look at an actual problem where you're dealing with angle addition postulate. If the measure of angle LYN, the whole thing, equals 125 degrees. They should have a degrees here, but that's okay. What are the measures of this angle and the measure of this angle? So they've actually worked this problem out for you, but I want you to see how they do it through algebra. They took the measure of the whole thing, which is 125. That's why they skipped down here to bring in at 125. And they made it equal 4p plus 7, because that's this angle, plus 2p minus 2, because that's this angle. And these two added together would be the total 125. So then they worked it out with algebra and got p equals 20. So p equals 20. And then it says, now that you know p equals 20, what are the measures of these other two? So you would just go plug in 20 for each of these, and you would solve it. 20, 40, 60, 80 plus 7 is 87 for the whole angle. And then if you know this is 87 and the whole total is 125, you could just subtract 125 minus 87, or you could go ahead and plug it in again. 20 times 2 is 40, minus 2 is 38. You can always check it by adding these together and making sure you get 125. Okay, and that is worked out actually right here and here. So we're going to move on to a couple of practice exercises down at the bottom. X is the interior of angle LIN. The measure of angle LIN is 100. I already think we need to draw this out. So if LIN is 100, I'm going to make it a little bit bigger than a right angle. All right, this is the measure of angle LIN. Okay, and what we know is that it measures 100 degrees. The measure of angle LIX is 14t. I don't know where X is. I'm just going to put it out here somewhere just so that we can have a visual. It doesn't have to be accurate, obviously, because we don't know how big these are. But the measure of angle LIX equals 14t. And the measure of angle XIN equals t plus 10. Okay, so again, we don't know what this is, we don't know what this is, but we know that total, the measure, equals 100. So let's go ahead and set it up. So we've got 100 total equals the 14t angle plus the t plus 10 angle. And we're just going to solve it with algebra. 14t plus t is 15t. Subtract 10 from both sides. 15t equals 90. Divide both sides by 15. 90 divided by 15 is, it's probably, what is it, 6? Let's just get out our calculator to double check. 90 divided by 15 equals 6, yes. Okay, so 6 equals t. So now that we know that 6 equals t, what are the measures of the two angles? So LIX is whatever 14 times 6 is. 84 degrees. Do the little degrees sign. And xin is 6 plus 10, which would be 16 degrees. So my pictures are way off. 16 degrees would have been a tiny little angle, but that's okay. I just needed a visual to be able to picture it. Okay, last one. Try this one on your own and then fast forward and see if you got the same answers I did. Z is the interior of GHI. So let's set this up. GHI equals 170. That's almost a flat angle. So 170 is almost a 180 degree angle. So that is GHI, GHI. And then Z is in the interior. So I don't know where it's at. I'm just going to add it there. It's probably off, but that's okay. I just need a visual. So it says the measure of angle GHZ is 3S minus 5, and the measure of ZHI is 2S plus 25. So I'm just going to add those up and make them equal to 170. I'll kind of make some space over here. So 3S minus 5 plus, because we're adding their segment addition, 2S plus 25 equals 170. Combine your like terms. 3S plus 2S is 5S. Negative 5 plus 25 is positive 20. Subtract 20 from both sides. 5S equals 150. Divide both sides by 5. S equals 30. I think that's 30. So the value of S is 30 degrees. And then if you go plug it in, 3 times 30 is 90 minus 5 would be 85 degrees. And then ZHI, 30 times 2 is 60 plus 25 is also 85 degrees. So actually, these two angles are congruent to each other.